Hello friends, this video is on how to do all the problems that are on the assessment. And that's going to make the video pretty long because I'm going to try to be as detailed as I can in my explanation of each problem. I would remind you that you only need to watch the video on the problems that you are wondering about. You do not need to watch the video from beginning to end. All right, so we're going to factor completely. So the first thing that I am going to notice is that the numerator, let's go with that. The numerator is the difference of two perfect squares. So that is the difference of two perfect squares, so it's going to be factored as such. So it is the difference of squares, so when it factors, it is going to be x plus 4 and x minus 4. Because the square root of x squared is x, and the square root of 16 is positive and negative 4. Then the denominator does not have a greatest common factor either, but the denominator, we are looking for factors of 20 that would add to negative 9, and they are negative 4 and negative 5. So the denominator is going to factor to x minus 4 and x minus 5. And I'm sorry I did not write that in the order that I wrote it, but my hand and my mouth apparently are not working together. Then we're going to reduce completely, and when we reduce this and we reduce that, there is our answer. And when we type that into Canvas, we must have the parentheses to say that the x plus 4 is totally in the numerator and the x minus 5 is totally in the denominator. So the parentheses are required to be correct. Okay, on the next one. The very first thing we look for is a greatest common factor. And there is a greatest common factor in this particular one. The greatest common factor of this particular one is 3x. So when we divide 3x away, we're left with x plus 5. Then we look at the denominator of that fraction. And when we look at the denominator of that fraction, we do not have a greatest common factor, but we do have a quadratic trinomial, and so we will be looking for factors of negative 28, whose sum is positive 3. So negative 28, whose sum is positive 3, would be x plus 7 and x minus 4. Okay. Then on to the next fraction, and it already is a multiplication problem, so we don't need to invert anything. We look at this, and it does not have a greatest common factor, but it is a trinomial who has a leading coefficient of 1. So we are looking for the factors of negative 35, whose sum is 2, and that would be x plus 7 and x minus 5. Because if we multiply, we get negative 35. If we add, we get positive 2. And then we look at the next denominator, and we look for a greatest common factor, and they do have a greatest common factor, and the greatest common factor would be 6x squared, and 6x squared would leave us, I'm sorry, not x squared, my bad, just 6x. So the greatest common factor is 6x. That will leave us an x squared minus 25. Now, the fun thing about that is this is still factorable, so we're going to factor it again. And so basically, we can factor it again, and when we factor it again, it would be x plus 5, x minus 5, because it is the difference of two perfect squares, because the square root of x squared is x, and the square root of 25 is positive and negative 5. So actually, let's just move this out and move this in its place. There you go. And then you're going to reduce anything that's absolutely identical. So first of all, interestingly enough, 3 reduces with the 6, making the 6 a 2, and the 3 a 1. And this x will reduce this x, they'll cancel. And the factor x plus 5 cancels the factor x plus 5. The factor x minus 5 cancels the factor x minus 5. And the factor x plus 7 cancels the factor x plus 7. So the only thing remaining is there is a numerator. There is a numerator of 1. And in the denominator, there is a denominator of a 2 and the factor x minus 4. And that is exactly how you can write it into Canvas. Somebody might also write into Canvas parenthesis 2 parenthesis x minus 4. That's also just fine. To do either one of those things is absolutely fine. So we are factoring completely and then we are reducing completely, friends, and that is the name of this game. So this is the exact same type problem. So I'm going to give myself a very long fraction bar, as this is a multiplication problem. I am going to look at the very first numerator, and I'm going to notice that the very first numerator has a greatest common factor of x. And when I factor the x out, I am left with x squared plus 6x minus 16. So now I am left with needing factors of negative 16 that add to 6, and that's going to be negative 8. Nope, that's going to be positive 8 and negative 2. So that's going to be x plus 8 and x minus 2, and that is factoring completely. Then we're going to look at the denominator, and the denominator does not have a greatest common factor. The denominator is a trinomial, so we do need factors of negative 32 that are going to add to 4. Negative 32 that add to 4 are going to be 8 minus 4. And so we are going to have parentheses x plus 8 and parentheses x minus 4. Then we move on to the next numerator. This is the next numerator. The next numerator does not have a greatest common factor. However, it is a trinomial with a lead coefficient of 1. So I'm looking for factors of negative 4 that add to negative 3. Those are negative 4 and 1. So I'm going to go x minus 4, x plus 1. That is now factored completely. And then I am going to factor this. And when I factor that, it does not have a greatest common factor, but I am looking for factors, and I'm looking for factors of negative 10 that add to 3. Negative 10 that add to 3, that's going to be 5 minus 2. So I'm going to go x plus 5 and x minus 2. And then I'm going to reduce anything in the numerator that's absolutely identical to anything in the denominator. So the x plus 8s are gone. The x minus 2s are gone. The x minus 4s are gone. So the only thing that survived being reduced, in the numerator, we have an x and we have an x plus 1. And in the denominator, we have an x plus 5. So it is fine to write your answer like that. If you would like, you could also write your answer like this. That is also just fine. Either of those things are fine. Both of them will be counted correct. Moving on. Okay. So when we look at this, we have f of x, and we have a negative 3x, and our powers of x. We have an x here and we have an x here. So our power of x is going to be x squared. Then when we go to look for our y-intercept, we need only take the negative 3 and the positive 8 and the negative 5 and multiply them together. And negative 3 times 8 times 5 is negative 40 times negative 3. So how about a positive 120? 40 times 3 is 120, yes. Okay, so by the fact that our highest power was 2, this is a quadratic. Which means it will have 2 zeros and 1 change in direction. It's the fact that it's a polynomial means that it will have a negative infinity to infinity domain. The fact that this is even, there we go, and the fact that this is negative means it will take on a shape that looks like this. So if it takes on a shape that looks like that, both the ends are headed down. So the end behavior is D, and the range is coming from negative infinity to an absolute maximum. Because down here is negative infinity, and up here is a max. The y-intercept is 0, 120, and the x-intercepts, if I take x plus 8 and set it equal to 0, I get x equals negative 8. And if I take x minus 5 and set it equal to 0, I get x equals 5. So I have, this is a negative 8. Negative 8 and 5. No spaces, no commas. Moving on up. All right, here we go. So this begins with f of x equals x to a power of. And when I look at this, I have a power of x here, here, and here. That's going to give me 3 powers of x. Also, because it leads with x in front of the parenthesis, that means that there will not be a number the only number at the end is 0. So that means my y-intercept has got to be 0, 0, and I have to have 0 in my answer. I don't know where it fits in all the other answers, but I know I will at least have 0 for an answer. It is a polynomial, and by definition, all polynomials have a domain of negative infinity to infinity. That is part of the definition of a polynomial. It is a cubic because it has 3 powers. It is a cubic because it has 3 powers, which means it will have 3 solutions, and which means it will have 2 changes in direction. Because this is odd, and because this is positive, it will most take on a shape like this. Whoops. Well, yes, that, but mostly like this, which means it's going to be negative infinity and infinity as far as that is concerned. So the range is also going to be negative infinity to infinity, and this answer is A. So now all I need are the other values of x. So I have a factor of x plus 6 equals 0. That means x is going to be negative 6. And I have a factor of x plus 1 equals 0. So that means x is going to be negative 1. I also had a factor of x equals 0, but I knew that already. So I did know that already. However, I do need to move this down because he's now the biggest of all my answers, not my smallest. So my answers are negative 6, comma, negative 1, and 0. No spaces and no comma after the negative 1 and before the word and. Alrighty. Moving on to negative 6, or question 6. Hello. Question 6. On question 6, I have f of x equals 4, and I have a power of x, a power of x, a power of x, a power of x. So I have x to a power of 4. I then am going to take the 4, the 8, the 2, the 1, and the negative 6. and multiply them all together. And that's going to give me a negative number. And 4 times 8 is 32. Doubled is 64 times negative 6. 64 times negative 6. 64 times negative 6 is going to end in a 4. 64 times negative 6. 36. 384. I think we get 384. All right, so let's check this out. We had 4 powers. That makes us a quartic, which means we're going to have 4 possible zeros, 3 changes in directions, and we're going to have a y-intercept of 0, negative 384. The domain, because it is a polynomial, the domain is negative infinity to infinity. Because this is an even number. Because this is a positive number. It is most going to take on this shape, which means it is headed towards infinity on both sides, which means it's going to be C, which also means it's going to have a minimum. So the range is going to be an absolute minimum to infinity. And let's talk about the x-intercepts. We have a factor of x plus 8. That means one of my x's will be negative 8. We have a factor of x plus 2, which means one of my answers will be negative 2. We have a factor of x plus 1, which means one of my answers will be negative 1. And we have a factor of x minus 6, which means we will have an answer of 6. So my x's are negative 8, negative 2, negative 1, and 6. And there we are. All right, moving on. Okay, these questions are undoing these questions. Specifically, this right here. If I were to tell you that I knew an answer was negative 8, you would tell me that you knew a factor would have to be x plus 8. If I told you I knew an answer was negative 2, you would have to tell me that you knew a factor would be 2. So if we go to this problem right here, and I tell you I know I have a factor of negative 5, you're going to say, if I have an answer of negative 5, here we'll do color. If I tell you I have an answer of negative 5, you are going to tell me that the only way I could have an answer of negative 5 is if I had a factor of x plus 5. And then you would say, if you know the answer is 3, then you knew you had to have a factor of x minus 3. And if you had a factor of 6, then you would know that you would need x minus 6 as a factor. Then what I'm going to ask you to do at this point in time is then to multiply them together. So we're going to leave the first guy alone, and we're going to do this multiplication piece. So we leave the first guy alone. The first guy is x plus 5. When we multiply x minus 3, x minus 6, we get x squared minus 9x plus 18. Now you can do that by multiplying those two things together. If you multiply those two things together, you would have x times x, which is x squared, and you would have x times negative 6, which is negative 6x, and you would have negative 3 times x, which is negative 3x, and if you'd have negative 3 times negative 6, you'd have plus 18, and you would have exactly what I said, which is x squared minus 9x plus 18. Or you could understand that you are undoing the factoring, which is negative 3 and negative 6 add to negative 9, and negative 3 times negative 6 multiplies to positive 18. Okay, but here's the deal. We are still not done. So now we need to do this multiplication. So now we need to take x times each of these. So all that does is raise each of these to a power of x. So that's going to make it an x third minus 9x squared plus 18x. And then we are going to take Let's do this green. Then we are going to take positive 5 and multiply each of these by positive 5. That's going to give me a positive 5x squared, a negative 45x, and a positive 90. Then I'm going to add them together. And when I add them together, I get x to the power of 3 minus 4, x to the power of 2, minus 27x plus 90. And that is the standard form. Yep. Number 8. Okay, in number 8, if I tell you I know I have an answer, and I know that I have an answer of 4, that means I have to have had a factor of x minus 4. Now then, if I tell you I know I have an answer of radical 13, then you also need to know that you can only have a radical if you have its opposite as well. So really, once you have one of those, you have to have the other. They travel in pairs. If they're square roots, they have to have their partner. So that means I am going to have an x plus radical 13 and an x minus radical 13. And it doesn't matter which one of those you put the plus, which one you put the minus in, but you need to write it like that. Okay, so then if you jump in and you decide that you are going to multiply these two things together, what you're going to have is you're leaving the first one alone. And so you have x minus 4. And when you multiply those together, you're going to have x squared minus 13. Now, if you don't follow that, then here's what you're going to do. You're going to take x plus radical 13, and you're going to take x minus radical 13, and you're going to do the math. And x times x is x squared, and x times negative 13 is negative square root of 13x. And radical 13 times x is positive radical 13x. And negative radical 13 times positive radical 13 is negative radical 169, which is 13. So when you add these together, these cancel out. This is really negative 13, and this is x squared. Okay? I would never write negative radical 169. I would just write negative 13. I like to think radical 13 times radical 13 is 13. I don't even do the 169 in my head. But at any rate, now we have this. So now we're going to multiply these together. And you can multiply these together in whatever order you want, but I can tell you the order that's fastest and most clear. If you take this times this, you get x to the power of 3. And then if you take this times this, this times this, you get negative 4, x to the power of 2. And then if you take this times this, you get negative 13x. And this times this, well, hello, again. You get positive 52. And so your answer is x raised to the power of 3 minus 4x raised to the power of 2 minus 13x plus 52. All right, here we go. Same type of problem. I tell you you have a negative 7. You should tell me that gives me a factor of x plus 7. I tell you you have a 3. You should tell me that gives you a factor of x minus 3. I tell you you have a negative 5i. You understand those have to travel in pairs. So if I give you the negative 5i, I've really given you the positive 5i as well. So that's going to be x plus 5i and x minus the 5i, and it doesn't matter which one of those you put first, the positive or the negative one. You're going to get the same thing. So now, because you have 4 of them, you can multiply them in pairs. So we can multiply these two together. And when you're done doing that, you can multiply these two together. When you multiply the first ones together, you get x squared plus 4x minus 21. And when you multiply the other two together, you get x squared plus 25. Now, I will slow down and show you that piece because that piece bothers people. If you take x plus 5i and you multiply it by x minus 5i. X times x is x squared. X times negative 5i is negative 5ix. 5i times x is positive 5ix. And positive 5i times negative 5i. Positive times negative is negative. 5 times 5 is 25. I times I is I squared. Then we add them together. And we have x squared. These two cancel each other out. Now, let's talk for a moment, friends, about this right here. We have a rule. And we have a rule that says I squared is multiplied by negative 1. So if I have negative 25 I squared, I have negative 25 times negative 1, which is positive 25. Okay? That's what I have. So that's where that comes from. So now, I don't know, maybe I should move it over so you can follow along. There you go. So now we're going to do the distributive property with these two. When I do the distributive property with these two, you can do them whatever order you want. I have found that this is easiest for me. X squared times x squared is x to the power of 4. X squared times 4x is positive 4x to the power of 3. And x squared times negative 21 is negative 21x to the power of 2. All right, then I'm going to do my 25. 25 times x squared is positive 25x squared. 25 times 4 is positive 100x. And 25 times 21 is 525. And we add that together, and we get x to the power of 4 plus 4x to the power of 3 plus 4x to the power of 2 plus 100x plus 525. And when you type that into Canvas, you're going to type x to a power of 4 plus 4x to a power of 3 plus 4x to a power of 2 plus 100x plus 525. Alrighty, next. Okay, this is not factorable. What are we on, number 10? This is not factorable because 39 and 54, they do share a 3. But I don't think they're going to share anything else. So we're going to go to, first of all, let's answer things we can answer before we start doing any terrible math. So this is a third power. So this is a cubic polynomial, which means it will have as many as 3 answers and 2 changes in direction. It has a y-intercept of 0, negative 54. And we need to find the x's. So we're going to go to our graphing calculator. Pull up our calculator. On our calculator, wait for it, we are going to go to y equals, and we're going to type in the question. And the question is x raised to the power of 3 minus 4x squared minus 39x minus 54. And we can hit graph if we want, negative 3, negative 2, and 9. Or we can look at the table. And right there at negative 3 is a 0. And at negative 2 is a 0. And at 9 is a 0. So those are our answers. So we are going to type, we're going to write negative 3, negative 2, and 9. And notice, 54 is divisible by 3, 54 is divisible by 2, and 54 is divisible by 9. Alrighty, next. Ooh, this one is not factorable, so let's put it in the calculator. So let's go to the calculator. Let's go to y equals, clear what's there, and let us write x to a power of 4 minus 3x to the power of 3 minus 19x squared minus 27x minus 252. And let's hit graph. 1, 2, 3, negative 4 and 7. Negative 4 and 7 look like it's it. And right here we notice at 7, we have a 0, so for sure, 7. And if we go up to negative 4 for sure also. So we know those two answers. So we know for sure we have the answers of negative 4 and 7. Let's answer the rest of our things before we get going. I'm sorry, I got out in front of my skis. This is the second power. So this is a quartic, because quart means 4. So we'll have as many as 4 solutions and 3 changes in directions. So it's going to look like this. And the y-intercept is negative 252. So as an intercept, it is 0, negative 252. And we know we have 2 out of 4 answers. And we know the other ones must be imaginary because they didn't show up on the graph. So here's what we're going to do. Let's first of all get this out of my way. All right. So we know one of the answers. We know one of the answers is negative 4. So one of the answers is negative 4. So we are going to then take the coefficients. And the coefficients are 1, negative 3, negative 19, negative 27, and negative 252. And we are going to write 1, negative 3, negative 19, negative 27, and negative 252. We're going to leave a space, put our line, and pull down our first number, and then we're going to multiply, add. 1 times negative 4 is negative 4. Negative 4 and negative 3 are negative 7. Negative 7 times negative 4 is positive 28. 28 minus 19 is 9. Times negative 4 is negative 36. Added, you get negative 63. Negative 63 times negative 4 is positive 252, which means we have no remainder, which we knew that was going to be the case. Our other answer is 7, so 7 now gets to go in the box. So we put 7 in the box, we put in equals bar. I'm going to pull that up just a hair so I have room to write. And then we are going to bring the first number down, and we are going to multiply. 7 times 1 is 7, minus 7 is 0, times 7 is 0, times 9 is 9, times 7 is 63, and again we got 0. Fabulous. So we started with x to the 4th power. We used synthetic once, so that got us x to the 3rd power. We used synthetic again, so that gets us x to the 2nd power. So we have 0, x to the 2nd power, plus 0x plus 9 equals 0. So that gives us the problem, x squared plus 9 equals 0. We solve. X squared equals negative 9. X equals a positive and a negative 3i. 3i because the square root of radical 2, and the square root of negative radical 9. The negative gives you the I, the square root of 9 is 3, and the square root is a plus minus. So we're going to say and plus minus 3i. And now we have 4 answers. This one is probably factorable. And I am going to say, I'm going to do it by guess and check. And then we could also do it by synthetic division. It has to lead with 3x. And it has to lead with x. Because if I take this and multiply it by this, I need to be able to get that. Factors of 28. Factors of 28 are 1 and 28 2 and 14, and 4 and 7. So if I put plus 4 here and minus 7 here, that's not going to work. Okay. So 14, 2, maybe. If I put 2 here and 14 here, that would be 6 and 14. No. And I need a 25, right? Oh yeah. How about 28 and 1? That'll do it. And this has to be the negative and this has to be the positive. Okay, so what I did there, friends, was I did a lot of mental math. But if I take this times this, I get 3x. And if I take this times this, I get negative 28x. And if I add them together, I get negative 25x. And negative 28 times 1 is that. And so if I solve this one, I would get x equals negative 1. And if I solve this one, I would get x equals 28 over 3. Now, chances are you don't want to do it that way. And I completely understand that you don't want to do it that way. So what you would probably do is grab your calculator. So you grab your calculator, you go to y equals, you clear what's there, and you type in the question. And we are doing 3x squared minus 25x minus 28. And you go to graph, and you see it hits once real pretty at negative 1, and then 1 not so pretty between 9 and 10. So if you want to double check, you can see at negative 1, you get a 0. And between 9 and 10, you don't get a 0. But you know there has to be a 0 between 9 and 10 because these change from negative to positive. So it had to go through 0 to make that happen. So, but here's the deal. We do know that negative 1 is an answer, right? We know that negative 1 is an answer. So put negative 1 in synthetic division. So we're going to put negative 1 in synthetic division. Maybe I should answer all these other questions first. Put negative 1 in synthetic division. Synthetic division, we are going to use the 3, the negative 25, and the negative 28. So we're going to write 3, negative 25, and 28. We're going to leave a space and put our bar. Okay, before we do that, let's say that this is a quadratic. And that's the reason I thought I could factor it. It can have as many as 2 solutions, 1 change in direction, and its y-intercept is going to be 0, negative 28. So I bring the first number down, we get 3, this is negative 3, this is negative 28, this is 28, this is 0. So then, just like we had in the problem before, this would be 3x minus 28 equals 0. So 3x minus 28 equals 0. So 3x equals 28. So x equals 28 divided by 3. Which is why that's our other answer. Okay? All right. Number 13. I would definitely use synthetic division because I'm not a huge fan of long division. I remember that was, when I was younger, long division was a 5th grade subject. And that was when I knew that my history, my life in math was going to suffer. Because I never understood long division when I was little. I don't think I got it for a long. I think I was an adult by the time I figured out long division. All right. So, we're going to take the numbers in front. Oh, no. Yeah, negative 4, negative 27, negative 14, 27, and 22. So we are going to put negative 6 in the box. And we're going to put negative 4, negative 27, negative 14, 27, and 22 out front. And give yourself a space and bring the first number down. Negative 6 times negative 4 is 24, minus 27 is negative 3, times negative 8, negative 6 is 18, minus 14 is 4, times negative 6 is negative 24, add is 3, multiply is negative 18, add is 4. So this answer is no. Alrighty, and by the way, that answer is no, but this number and this number make the ordered pair. So the ordered pair is negative 6, 4. And the answer is negative 4 x to the power of 3 minus 3 x to the power of 2 plus 4 x plus 3 plus 4 divided by x plus 6. And that's how you type that into Canvas. Oh, this one is going to require long division. So this one is going to require long division. Before we get started on the long division, I would like to remind you that if this is 4x minus 3 equals 0, then 4x equals 3, then x equals 3/4. So this is either going to be 3/4 or 3/4 is going to be part of my ordered pair, depending on if my answer is yes or no. So now we're going to do the math. So now we're going to take this, and we are going to use it as the divisor. That is terrible. There we go. This, which is the dividend. There we go. All right. So are we ready? So here we go. We are going to take this first term and we're going to divide it by this first term. And when we do that, we get negative 3x to the power of 3. Then we are going to multiply. We're going to take this times this and this times this. And when we do that, negative 3x to the third times 4x is negative 12x to the fourth power. And negative 3x to the third times negative 3 is positive 9x to the third power. I am then going to put my equals bar. And I'm then going to remember I'm supposed to subtract. But since I'm not very good at subtracting, I'm going to change my signs and turn it into an addition problem. So I change both of my signs. When I do that, these two cancel out like they should, and 17 minus 9 is 8x to the power of 3, and bring down the next term, x squared. Then I am again going to take the first term and divide it by the first term. And when I do that, 8x to the third power divided by 4x is plus 2x to the power of 2. I am then going to take and distribute. So I am going to take 2x squared times 4x squared and get 8x cubed. And 2x squared minus 3 and get negative 6x squared. I am then going to put my equals bar. I am going to remind myself that I should be subtracting, but I don't subtract well, so I'm going to add the opposite. And that makes these two cancel. And 10x squared plus 6x squared is 16x squared, and bring down my next term. Then I am going to take this first term and divide it by this. And 16 divided by 4 is 4. So 16x squared divided by 4x is 4x. So I have 4x there. I am then going to distribute. I'm going to take 4x times 4x and 4x times negative 3. And 4x times 4x is 16x squared. And 4x times negative 3 is negative 12x. I'm then going to put my equals bar. I'm then going to remind myself that I'm supposed to subtract. I don't subtract well, so I'm going to add the opposite. These two cancel. And negative 8 plus 12 is 4x. And bring down the next term, which is negative 3. I then am going to repeat the cycle one more time. And 4x divided by 4x is 1. 4x divided by 4x is 1. And 1 times 4x is 4x. and 4x times negative 3 is negative 3. And when I take their difference, there is no difference. So I have no remainder. So this answer is yes. And this right here is my answer. So I'm not going to do that though. We're going to write it. So my answer is negative 3x to the power of 3 plus 2x to the power of 2 plus 4x plus 1. And we are ready to move on. Okay, g plus j. This is g. So that's g. So I'm going to take g plus j, and then in a minute I'm going to have to distribute. So we'll do that up here. Okay, so g plus j. Where's j? Here is j. G plus j. So right there is g plus j. Put an equals bar. And I get 5x plus 7. All right, the next one is gf. So now I need f. This is f. So I'm supposed to be multiplying these things together. So I'm going to take g and multiply it by f. And I'm going to do this correctly. So I'm going to take 9x times 8x squared, which is 72x to the power of 3. 9x times negative 15, which is negative 45, x to the power of 2. And 9x times negative 12, which I think is 108x. Then I'm going to take 12 times 8, and that's going to be a 96, x to the power of 2, and 12 times negative 5 is negative 60x, and 12 times negative 12 is negative 144. And then I'm going to combine those two answers, which gets me 72 x to the power of 3 plus 51 x to the power of 2 minus 168 x minus 144. Alrighty. Starting at the far left, the first piece. So if we look at the first piece has a second power. So the first piece must be a quadratic. If we look at the next piece has a first power. So a power of 1 is linear. If we look at the next piece has a second power. Hello, highlighter, please. Has a second power. So the next piece is also a quadratic. And if we look at the last piece only has one variable in it. That makes it a constant. Now, some of you are wanting to write linear, and you're right, it is a line, but it's specifically a horizontal line. That makes it a constant. The domain is negative infinity to infinity. Negative infinity to infinity. And the reason for that is because from negative infinity to negative 3 to 2, 2 to 8, and 8 to infinity, nothing is missing. So if nothing is missing, that's what you have. The range, on the other hand, this goes down forever. So it goes to negative infinity. But, right here is a point. And that point is something 9. And I know that's something 9 because here's 9, and here's 8, and here is 7, and here is 6. And so it is something 9. So the range is negative infinity to 9. Okay. The intercepts are... let's get a bigger dot. There's an intercept here. Oh, let's do this in, yeah. There's an intercept here, 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 which I gave to you because it was ugly, here, and here. So what are those numbers? Those numbers are -10, -4, 4, and 6. So, I think we could go smaller. -10, 0. -4, 0. -0.667. 0, 4, 0, and 6, 0. How good is my memory? Pretty darn good. All right. Oh, and the y-intercept? The y-intercept is right here. And that would be the number 2. So the y-intercept is 0, 2. Okay, on this one. First of all, let's notice, please, that this is everybody smaller than -3. So this is smaller than -3, this is smaller than -3, this is smaller than -3. So that function is going to work for those 3 numbers. This is between -3 and 2, inclusive. So between -3 and 2, so that is only that one. Okay. This one is between 2 and 8. So between 2 and 8. So that's this one, and this one. And then the remaining piece must be 8 or bigger. And just as a coincidence, it is 8. So that's going to be this, and this, and this. And we know those are going to be 8s. 8, 8, and 8. All right, the -20 is the only thing we're not going to see. So let's take this and copy it for me. And so we are going to use -20. So we're going to say f of -20 is -20, negative parenthesis, -20 squared minus 14 times -20 minus 4d, minus 40. And then you can do it on your calculator. I'm not going to do it on the calculator because I'm just right here, so why don't I just do this? That will be a -400. This will be a positive 280. And this will be a -40. So 440 minus 280. 0, 6, -160. So that will be a -160. Of course, I don't expect you to do that by hand. But here's the thing. -10 is right here. That's the ordered pair. -10, 0. So 0. And -7. -7 is right here. So that is -7, 9. So this is a 9. -2 is our next victim. -2. -2 is right here. So that would be down here. Which that's -1, -2, -3, -4. So that would be -2, -4. So -4. Then we want 3. 1, 2, 3. And let's go up and hit here. that is 1, 2, 3. So that's the ordered pair 3, 3. So that's a 3. The next one is a 4 right there. So that's 4, 0. And the next one is a 7. So this is where 7 is. So right there. And that is 7, 3. So that is a 3. And there is that answer. All right. Okay, here we go. The rocket left from the ground. That is the answer to that question. The rocket left from the ground. So here's the deal, my friends. Here is your time axis. That is pretty pathetic. Let's try one more time. This is time. This is height. And this is a quadratic. That's going to take on this shape. And there's no number at the end, so it's going to begin at the origin. Okay? Then, let's do this color. This color right here is the max. And we will find the first piece by negative b over 2a. And we will find the next piece by putting that answer, whatever that answer is, in the problem. Okay? And then to do this piece, we are going to do t equals the opposite of b minus the square root of b squared minus 4ac divided by twice a. All right. And then also this one. What is the height of the rocket after 4 seconds? So when we go to do 4 seconds, we are going to say, we're going to take, nope, we're going to take this equation right here. And we're going to do it with 4 seconds. So we're going to say h of 4 equals negative 16, 4 squared, plus 75 times 4. You can put that in your calculator. That's 300. You can put it in your calculator. You do not need to do it by hand. I'm doing it by hand because I think I know it. I think that's 44 feet. Okay, so that's that one. At 4 seconds, we don't know the answer to that yet. To the nearest hundredth of a second, how long did it take the rocket to reach its maximum? So to do its maximum, here, let me do this. Okay, so to reach its maximum, I'm doing that in green. So that will be t equals the opposite of 75 over 2 times negative 16. At 4, nope, to the nearest thousandth. How long did it take the rocket to reach its max? So 75 divided by 32. So 75 divided, oh darn it, 75 divided by 32. So 2 something. 75 divided by 32. 75 divided by 32. 23438. 234,375. 234,375. 234,375. 234,375 is what the calculator said. And the problem says to round to the nearest thousandth. So that would be 2.10 hundredths thousandths. So 2.344. So then we want the maximum height. So to get the maximum height, we're going to take this answer right here and we're going to put it into the problem. This one I won't do by hand. So I'm going to take h of 2.344 and I'm going to go negative 16, 2.344 quantity squared plus 75 times 2.344. 2.344. So h of 2.344 is going to equal what? So 2.344. So let's go here and let's go negative 16, 2.344 quantity squared plus 75, 2.344. Close it, enter. 87, 89, so 88 feet. 88 feet. So that is an 88. Where's my, thank you. To the nearest foot, the maximum height is 88 feet. Okay. Nearest thousandth of a second, how long did it take the rocket to hit the ground? All right. So that's what we're going to do in pink. So we're going to do this in pink. So we're going to say t equals negative, and b is 75. Negative 75 minus the square root of 75 squared. And if you continued on, marker's so fat. If you continued on and put minus 4 times negative 16 times c, you would notice that this piece right here is just the number 0 because it's times 0. So what it is negative 75 minus 75, which is negative 150 divided by 32. So 150 divided by 32. So 150 divided by 32. You can type it all in your calculator. 4.6875, 4.6875, 4.6875, 4.6875. Whoa, howdy, 4.6875. 4.6875 is how long it takes to hit the ground. And it said it wanted it to the nearest thousandth. So 4.10 hundredths thousandths. So this would be falling. Because it only took 2 seconds to get to its highest point. So at 4 seconds, it would definitely be falling. All right, that's that one. All righty, number 19. Woo! Okay, that's going to be fun. All right. Let's just see if we can... Can't believe it broke it up like that. All righty, so XGHS. XGHS equals 540. And I'm going to write it down here. 1934X and 11080G and 1101H and 997, 997S equals $28,389.80. That's a lot. 10 more punches. So there are more punches. And punches are the H. So the H equals the other guy plus 10. And staplers are S's. Okay. And then, so that's what's going to go here. H equals S plus 10. And then the other one is, write the equation 8 times the number of graphing calculators as whole. So 8 times the number of graphing calculators as whole punches. So there are more graphing calculators. So there's more of those. So the graphing calculators, we would need to take our hole punches and multiply them by 8 to get as many hole punches as graphing calculators. So G equals 8H. So if I were to put these in order, what a mess, then, stop it, then I would have X, G, H, S, and the number. And the green equation would be 1H, negative 1S, and this would be 10, and these are filled with zeros. And the other equation would be a G and a negative 8, and the rest of these would be filled with zeros. And then we're going to put that in the calculator. Okay, well this is going to be a feat. So, in the calculator, second matrix, edit. And there were 4 items. This is a 5 by 4. Nope, a 4 by 5. 4 by 5. Yes. 1, 1, 1, 1. And there were 540 items. Then our amounts are $19.34 and $110.80 and $11.01. And I lost a number. Did I lose? No, I did not. $9.97. And I spent $28,386.80. Ooh, I needed a decimal somewhere. Something there is not right. Let me try that one more time. So what was it? It was 28, 389 and 80 cents. Oh, it rounds it up. I wonder if it's holding the number though. I think it rounded it up just to make it fit. Wow, that's going to be a problem if that's not true. Okay. So then 001 negative 110. 001 negative 110. 001 negative 110. Yes. And 01 negative 8. 01 negative 8. 0, 0. All right, I think it's all in there correctly. So second matrix, and we'll go up to reduce row echelon form, and pick matrix A and cross our fingers. Yeah! I wonder if it's because of the fact that it rounded. Because those are so close to being whole numbers. I wonder if that is the case. Let me see if I can find the actual test. That is not Algebra 2. Do I have Algebra 2 open anywhere? I think it's because it got too big and it rounded that number. Dang it. Dang it, dang it, dang it. Let's see, friends. This question has been on an assignment before. Nobody mentioned that, or I have something in the wrong place. Those are so close to whole numbers. So close to whole numbers. Yes, that's what happened. So it is 300, 200, 25, and 15. 300, 200, 25, and 15. The reason those didn't come out to be whole numbers is because this matrix changed the amount of money to a dollar amount because it was too many digits to fit in the box. Okay, so here, let me do this. Let me take all the decimals out. 1934, 110, 8. Ooh, that needs a 0 with it then. 1101, 997. And this would be, I think it's still going to do it. What was the amount of money? 28, 389, 80. Ooh, I changed it to scientific notation. So that still may not. Yep. That's just too big of a digit, too large of a number to make it fit in the matrix. So just round all those numbers correctly. So 300, 200, 25, and 15. So 300, 200, 25, and 15. I should put a note on that everybody needs to round. Okay, I'll put a note on that. Sorry. Okay, this one. Oh, yes. So basically it comes down to this. We have yes votes. We have no votes. And we have total votes. And we don't even have to read it. We can just pull numbers out. So it says, on April 2nd, 2024, the residents of Jackson County, Missouri will have the opportunity to vote on a 3/8 sales tax, which would allow the Kansas City Royals to build their new stadium in the Crossroads area of Kansas City, Missouri. A survey of 154 people. So they asked a total of 154 people. So this is a very poor sample size because there's 7,000 people who live in Jackson County. But they talked to 145 of them. A survey of 145 people was taken asking if the person was supportive, yes, opposed, no, or undecided. Ooh, I need the undecided group. I forgot about the undecided group. The undecided group. How many people were in each category? Okay, so, I really should. It really isn't a very good test question because those numbers should be in the problem just in case the graphic doesn't show up. So I should check that one too. 32, 59, and 9. 32, 59, and 9. 32, 59, and 9 when we did as percents. So let's find the number of people who were a yes vote. So let's make these yes votes. So that would be the math problem. 32 100ths is equal to y over 145. So 145 times 32 divided by 100. 145 times 32 divided by 100. And we can't have partial people, so we'll make it 46. We can't have partial people, so we'll make it 46. If we want to do the no votes, don't use red, pink rather. That would be 59 100ths equal the no votes over 145. So 145 times 59. 145 times 59 divided by 100 to make it a percent. And that's going to make it 86 people. 86 people. 86. So that's 86. So the other people are 145 minus 132. So 13 people who couldn't make up their mind. Yes, there we go. All right, my friends, that is it. I hope that helps. You're welcome to communicate with me in class or via email if you have any more questions. Thanks, friends.